Hi, good evening all. Myself Chitra, working as assistant professor in MIT in the Department of Artificial Intelligence and Machine Learning. Let us see what may be the purpose of analyzing an algorithm. Algorithm is, as we know already, it is a set of process or set of rules that can be written in a programmatical manner which is furtherly executed by a programmer to solve a problem. So before selecting any algorithm, we need to find out the time taken by that algorithm, whether it is minimum or maximum. So among those algorithms with different execution timings, the algorithm which is having minimum has been selected, which is termed as a better one. Let us see the objectives of doing time complexity analysis. The first main reason will be comparison of algorithms, because each and every algorithm can do its execution in different manner. In different manner in the sense, any algorithm can have different execution time for processing. Among those algorithms, we need to select a better one. So that process is considered as algorithm comparison. The next objective of doing this analysis is performance prediction. Every algorithm can have its own performance level. In the sense, how long an algorithm will take to execute its process is termed as its performance. So we can predict an algorithm which is having fastest time of execution as a better performance. The next objective of analyzing an algorithm is scalability, which means that any algorithm can be capable of doing its analysis process even though the input size increases, which means that an algorithm should not disturb its execution in the time of varying the input size. The next objective of doing analysis is optimization focus, which means that nowadays all the real-time applications are implemented using some algorithms. So before implementing any logic into a program, the better algorithm has been selected. That betterness is selected by the process of optimization. Optimization is the process of selecting a best algorithm. At last, the main objective of doing time complexity analysis is resource management. So also the time complexity analysis process plays an important role which leads in efficient resource management. So we can conclude the time complexity of an algorithm as the amount of time taken by an algorithm during running as a function of input is varies. So we can say that length of the input is directly proportional to the number of operations that algorithm possess. We can also say that the algorithm will provide concise output depending upon the number of input increases. Next we'll see about different types of time complexities. Based on the number of statements executed per unit time, the time complexity analysis is divided into different categories. Those categories are constant time complexity, logarithmic time complexity, linear, quadratic, and order of n log n time complexity. Let us see about the first type of time complexity known as constant time complexity. From the name itself we can understand, after analyzation is over, the time complexity for this type of algorithms will be a constant value, which means that each and every statement in an algorithm takes a unit time of execution. That is, cumulatively we can calculate the analysis as a summation of each and every unit times carried out by each and every instruction in the algorithm. So the time complexity for constant type will be order of 1. Let us see an example which illustrates you a constant time complexity with an example of evaluation of Fibonacci series. Look at this example. Each and every statement can have a unit time of execution. For example, the first 4 statements takes a unit time of execution, which is mentioned as here +1, +1, +1 and +1. And for looping statement, the looping statement will be executed for n number of times. It may iterate depending upon the value of n. So, the statement present within the looping will be executed for n number of times. And for the return statement, since it is a single statement, it takes unit time of execution. So totally, the timing needed for executing this algorithm is n number of times for looping and 5 number of times for other statements. So totally, the time taken for executing this algorithm is n plus 5. So collectively it can be written as order of n plus 5, again which is termed as the maximum value as execution time order of n. Note that constant part does not affect the overall time complexity. So maximum number of instructions executed will be taken as total time complexity for constant TC. Next we'll see about linear time complexity. While we are talking about constant time complexity, listen to this graph. This may be the graph for a constant time complexity because whenever the input has changed, for example, if the input is 1, the CPU timer is of about 5 milliseconds. For example, we can take for the input 2, again the time taken is 5 milliseconds. For the input 3, again the time taken is 5 milliseconds. Even though if we are changing the input to n, the time taken for executing that particular algorithm is simply 5 milliseconds. So we can have the graph like this, a constant line. So this is termed as constant time complexity. Now if we look at linear time complexity, we know the term linear, which means that for increase in one parameter value, the other parameter value also increases linearly. For example, a diagonal line in a graph shows you the concept of linearity in a problem. Okay. Now, as per the statement given over here, when the running time of an algorithm rises linearly with the length of the input, it is termed as linear time complexity. When the function checks all the values in an input data set, which means that every input has been passed as a parameter to a function, the function has to be evaluated by taking the input value. Whether the input value is greater or lesser, the function will be executed. Suppose the input data value is increased. For example, if you are finding out square value, that is n square. Suppose if you are having value of n is 5, if you are going to find out the n square value, the value will be 25. Suppose if your value of n becomes 1025, the evaluation process should take some more time for calculating n square value, which may be a large value. Okay, so for each and every increase in input, the algorithm will take tremendously extra time for execution. So for increase in input, the processing speed also increases. So the linear time complexity will take the time complexity of order of n. Let us see an example which illustrates the linear time complexity. This is a program which is going to print 5 elements which are already stored in an array. In this program, we are having 2 statements which are of unit time for execution. That is array initialization, where an array is declared here with 5 elements which can take 1 unit of time for execution. And also the print statement can take 1 unit of time for printing a single value of an array. But look at here in for loop, the printf statement has been executed for 5 times, ranging I value from 0 to 4. So here the value of the number of times the for loop statement has been executed as n number. If n is equal to 5, it may take 5 unit time. So total time taken for this is taken as n plus 2, where n may be 5 for this particular algorithm. If n values ranges, also the time execution varies, which means that increase in input also increases the execution time, which may come under linear time complexity. The order of linear time complexity can be represented as order of n, whereas in constant time complexity, the time complexity is termed as order of 1, which is a constant. The next type of time complexity algorithm is logarithmic time complexity. In this algorithm, for each and every iteration of execution of an algorithm, the input data is comparatively reduced. It depends upon the number of inputs. For a large type of data, this method of logarithmic time complexity algorithm has been used. From the point of what I given over here, when the algorithm lowers the amount of input data, then it is termed as logarithmic time complexity. This type of time complexity has been used in executing binary search tree or binary search algorithm. Let us see an example which illustrates you logarithmic time complexity. Let us take an example of binary search algorithm. As we know, searching process can be done in two ways majorly. First one is linear search. In linear search, each and every element has been compared with the key from the starting to end of the array. Instead of in binary search, the searching process has been done on a sorted array, because sorted array can be divided into two parts based on which the key element has been searched in first part or second part. Let us see this example. If the searching element is present at the first part of the array, so first part in the sense, the array can be divided into two parts. So the two parts has been achieved after finding out the middle element of the array. Based on the middle element of the array has been divided into two sections. So the middle has been calculated by this formula. Suppose if your array is having 10 elements. For example, consider this as an array. Your key value is 3. Now we are going to search for the value 3 in this array. Have a note of this as doing binary search, the list should be in sorted. So in binary means 2. So we are dividing the array by 2. So dividing the array by 2 in each and every iteration, the entire input size is going to be reduced comparatively more than the previous two time complexities. So after finding the middle element, we are comparing the middle element with the key value. If the key value is lesser than the middle value, the again search process is proceeded in the first half of the array, that is from lower limit to the middle element, which means that according to this statement, the key value x is lesser than the middle value. At that time, the searching process is carried out from the first portion to the middle element, which means that lower limit L and then mid minus 1, which is the position next to the mid. It may be mid or mid minus 1 depending upon the number of input. That is, the n may be odd or even. For odd number of inputs, the term is taken as mid. For even number of inputs, the term taken as mid minus 1. So key value, if it is lesser than the middle value, the first portion, that is from 1 to middle portion, the searching process is carried out. Otherwise, the searching process is carried out to the second part, which means that we are entirely omitting one portion of the array in searching process. So this method of omitting a part of the input or reducing the number of inputs comparatively more than the previous two methods is termed as logarithmic time complexity analysis. So this is the notation for writing time complexity for logarithmic time complexity, which is order of log n. Let us see an example which shows you binary search algorithm analysis. Let us take an initial array of length n. During first iteration, the array can be divided into two halves. So that we are using here n by 2. Again, for the second iteration, again we need to find out the middle element of n by 2 elements. So the array is again furtherly divided into n by 2 divided by 2, which is termed as n by 2 square. Like that, if you are doing a k number of iterations, the expression may be n divided by 2 power k. So finally, after doing this calculation, the time complexity analysis for logarithmic analysis is log n base 2. The next type of time complexity is quadratic. When the execution time of an algorithm rises non-linearly, which means that a dramatic increase in input will lead to more number of execution time. That particular algorithm can be evaluated based on the type of quadratic time complexity. For example, we are having looping statements in major algorithms. Nested looping or nothing but repeating a particular statement for more number of times in execution. So at that time, execution time is more while comparing with other methods. For example, the nested loop contains a single nested loop may have two looping statements for iteration for the variables I and j. At that time, the time complexity is order of n square, where order of n is for one looping. For example, the variable I iteration, and another order of n may be for the variable j iteration. So if you are repeatedly multiplying or repeatedly executing the statement within the nested loop, the time complexity will be of order of n square. Now let us see an example which shows you the quadratic time complexity. As I said already, here we are having two looping statements. J loop is an inner loop and I loop is an outer loop. So one loop has been written within another loop, which is termed as nested loop over here. If you want to print a two-dimensional array element which is of size n by n matrix size, we can write the statement like this. This printf statement has been executed j number of times and multiplied with I number of times. So the execution time increases by I into j, which is commonly termed as n square, because I ranges from 0 to n minus 1, and j ranges from 0 to n minus 1, which is termed as n number of times for each and every variable. So n into n, which is of n square order. This is considered as quadratic time complexity. At last, we can conclude that the time complexity is a process regarding the algorithm analysis by which we can understand the time of execution increases with the time of operations make using the inputs. That is, increase in input will leads to increase in execution timing of the processor. Thanks for watching this video.